Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's The Battery Show and Electric Hybrid webinar, utilizing bidirectional converters in EV and automotive applications, sponsored by Calex Manufacturing and broadcast by Informa. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, this webinar will be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in our Q&A session that takes place at the end of our presentation. The slides will advance automatically throughout the event, and you may also download a copy of the slides via the resources widget. Toward the end of our webinar, we will ask you to complete our survey found on the right-hand side of your screen. Please take a moment to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. And lastly, if you're experiencing any technical problems, please click on the Help widget found at the bottom of your screen or type your issue into the Q&A text area, and we will be glad to offer one-on-one assistance. And now, on to the presentation, utilizing bidirectional converters in EV and automotive applications. Discussing today's topic is Michael McNally, Director of Product Marketing, Calex Manufacturing, Incorporated. Michael serves as Director of Product Marketing at Calex Manufacturing. He began his career with the company in 1998, designing DC-DC power converters, many of which are still in production today. Throughout his tenure with Calex, he has held a variety of roles, including Product Manager, Director of Sales and Marketing, and now his current position, where he is responsible for managing and marketing new products. Michael earned a Bachelor of Science in Electrical Engineering at California Polytechnic State University in San Luis Obispo, and he enjoys spending time watching football and working on cars with his son, his 17-year-old son, as well as hiking and bike riding in the great outdoors of Colorado. It's with great pleasure I now turn this special session over to Michael to begin. Michael, take it away.
Thank you, Chris. As you said, my name is Michael McNally. I am the Director of Product Marketing at Calex Manufacturing. And I would like to cover some topics today of utilizing bidirectional converters in EV and automotive applications. Today's vehicles consume more power, which makes it more economically feasible to store the required energy in 48-volt systems. Some of these automotive loads can be moved from the 12-volt system to the 48. Adding a 48 system to an existing 12-volt system doesn't require a complete redesign. These systems that are being added can be added right on with the existing 12-volt systems. A couple fundamentals for going to the 48. I'd like to cover SELV limits and a quick summary on lithium ion batteries. So when I reference SELV, as you can see from the slide, when you're doing SELV voltages, you're staying away from high voltage requirements and safety requirements. So SELV stands for safety extra low voltage. This comes from UL 60950-1, and that states that an SELV circuit is a secondary circuit which is so designed and protected that under normal and single fault conditions, its voltages do not exceed a safe value. So what that means basically for DC to DC converters is typically, unless your voltage is above 60 volts for a DC to DC, it's not applicable, because typically, if you're using a DC to DC where there's AC power, or what's referred to as an AC main, there'll be an AC to DC power supply involved, which has an isolation transformer. So in standard industrial applications where you're coming off an AC main, as long as you stay below the 60 volts, you don't have to design for these requirements. So example for the DC to DC basically is, in order to meet SELV, if there's any type of fault or anything, no voltage over 60 volts can make it through the converter. So this is one of the reasons why 48-volt electrical systems are a good idea for automotive. And discussing one of the customers at a test track in Michigan, have NDAs, I can't really say who it was, but one of the big three at the test tracks basically told us that, you know, the 48-volt systems for automotive are here to stay. And so, you know, staying under the SELV voltage rating is one reason for that. Other reasons for that is with the advances of lithium ion batteries, it allows systems to be created for this. I'm going to cover some advantages of lithium-ion batteries over the lead-acid batteries. As you can see, to start, for the same size or power, if you will, the mileage or the charge longevity, if you will, or I'll just say mileage as we show it here, miles, is going to be better on lithium-ion as compared to the same size or charge rating of a lead-acid battery. So lithium-ion batteries also last up to 10 times longer due to their efficiency. What this means for vehicle applications is allows vehicles and equipment to last longer, less downtime on the equipment. Lithium-ion batteries handle more charge cycles than a sealed lead-acid battery, allowing more cycles per unit. This also minimizes the downtime for maintenance on your systems. A big one here, lithium batteries can reduce the system weight by as much as 75%. Again, that's part of where the mileage came from on the first part of the slide here. So, you know, same power rating, you're, you know, reducing the weight by as much as 75%, which is critical on EV applications. Another advantage of lithium-ion is you're able to be fast charged to 100%, sometimes in as short a time as 30 minutes, while traditional lead-acid batteries can only be fast charged up to 80% at a much slower rate. So again, this reduces your system downtime while charging the battery. Another big one here is there's no need to be stored upright like a traditional lead-acid battery. Even though lead-acid batteries are labeled as sealed lead-acid batteries, they still have to be stored upright because there is a vent system in them, whereas the lithium-ion batteries are truly sealed batteries. So they don't have to be stored upright, so you can take advantage of, you know, put them in either marine application or RVs or whatever, any dead space that you can fit that battery in, it can be used. So it's another advantage over lead-acid. And then again, a lithium battery has more power than a compared size sealed lead-acid battery, again, which means, you know, less weight, more mileage. So a lot of advantages to using lithium-ion, and that's why a lot of the 48-volt systems are going to that. So combining the advantages of staying with under the SELV rating and taking advantage of lithium-ion systems, you can see why 48-volt systems are gaining popularity in the automotive sector. There you go. So what we're showing here is a basic example of a system. You know, again, all systems aren't identical, but this is a general overview of a 48-volt system. So, you know, you can see over on the 48-volt side, electric steering, air conditioning, all that, those loads have been increased to be able to handle the 48-volt system, while over on the 12-volt side, you can still use, you know, your existing 12-volt loads, such as headlights, radios, stuff like that. As I mentioned in the beginning, today's vehicles consume a lot more power just due to onboard computers and infotainment systems. The bidirectional converters are a very essential piece of this. As you can see from the drawing, you know, you've got the 48-volt system, so your inverter's there, you know, engine's running. So you can charge the 12-volt off the 48 via the bidirectional converter. And then if in emergency situation, if necessary, the 48, something happened to the battery, you know, emergency situation, the 12-volt can actually start the car via the bidirectional converter changing direction. So makes it, you know, usable to be able to run both of these voltage systems and have one converter that handles that. The 48, as I mentioned earlier, the 48-volt architecture can fit alongside an existing 12-volt system. And again, the advantage of that is you're not having to run any high voltage cables. You know, that cuts down on the safety requirements in the vehicles or whatever system you're running. So, you know, the bidirectional can be placed near the battery box. So, you know, all advantages of using a 48-volt system, you know, less current because of that. One of the big applications for this would be mild hybrid systems, or what's also known as MHEV. Mild hybrid cars use, as shown here, using a gas engine or internal combustion engine, if you will, utilize a 48-volt system, as the previous diagram showed, you know, for running either the supercharger, either the starter, any stuff like that. But when they're coasting, you know, sorry. So when coasting or cruising, the engine spins a motor generator to create electricity that can recharge the battery. So in the mild hybrid side, you can take advantage, and I'm sure either people have cars or rented cars to where, you know, you pull up to a stoplight or you're coasting, the engine will actually shut off and then restart once you start to accelerate. That's the mild hybrid platform working, and it takes advantage of the 12-volt system running the typical 12-volt loads, and then you have the 48-volt system. So again, key component for this is the bi-directional, because as you're running down the road, you know, the 48-volt storage system will be charged by the 12-volt alternator via the bi-directional converter. And then if some type of emergency where the 12-volt system has an issue, the 48-volt can supply the 12-volt loads via changing direction on the bi-directional converter. So again, as I mentioned earlier, auxiliary loads. Some of the auxiliary loads in the automotive systems are remaining the same for 12-volt loads. So anything such as driving lights, radios, interior lights, all can remain on the 12-volt bus, but they can also be supplied via the 48-volt storage system using the bi-directional converter. So I'll cover that more in some of the applications further along, but so you see just an overview of some of the systems that will remain 12 volts, even though some of the automotive systems are moving to 48, which brings me to energy storage. So with the improvement in the battery technologies, you know, for weight and power, it makes sense to store more of the power that's required in the 48. And as you can see here, as you know, as you're running down the road, 48s can charge the 12. Take advantage of that. Charge times of the lithium-ion batteries are much shorter than that of a lead-acid battery. So as you see, having 48-volt batteries on board, you store a lot more energy. Again, the use of the bi-directional converter is crucial here, because if you're storing power in the 48s and you need to convert it to 12, then the converter will operate in the buck mode, step the 48 down to 12, and take care of the 12-volt loads. If the engine's running and all is going well, then the 12-volt system's up and running. It'll use the DC to DC converter, change directions into the boost mode, and charge the 48-volt system. So it allows storing a lot more energy in vehicle and applications than just having the 12-volt system. So that brings me to some of the applications. So one of them we've seen in promoting our products is RV applications. So, you know, a typical recreational vehicle will have 12-volt system, standard internal combustion engine. So as the RV will run down the road, that 12-volt system, through the use of a bi-directional, can now charge the 48-volt batteries that are located in the RV. Once the RV stops and you want to utilize the 12-volt loads, the converter will go into the buck mode and supply all the 12-volt loads. What's advantageous about this is that reduces the need for running a generator. So the RV can use all your 12-volt loads while sitting idle, and then once you start the engine back up and run down the road, you'll recharge that whole 48-volt bank. So there's one of the benefits of using a 48 and 12-volt system. Another one that mirrors this one would be in marine applications. Same type of setup. You have an existing 12-volt system in boats or marine applications. So, you know, adding, as shown in the picture, adding a 48-volt bank down there, probably, you know, any place you got extra space, maybe back in the back of the boat or up front. Either way there's dead space, you can hide the 48-volt battery, and then, you know, as you're out driving the boat, 48-volt system is going to charge. When you stop, you know, you're still running GPS, depth finder, radio, entertainment stuff, anything like that. You have a longer life to run all your auxiliary loads without having to run the engine. So you can sit out on the water for a lot longer time. So that was a bit of a highlight of the BCA platform, which I'll get into later on in this presentation. But what we're seeing is not only is there a push for passenger vehicles and commercial trucks heading to the EV market or the hybrid market, is also construction equipment, agricultural equipment, any type of industrial equipment is also heading down that path. So I wanted to do a brief explanation of this diagram that was shown in the video. So over on the left side, you can see there's the AC input. So that is a picture of a 6.6 kilowatt charger that we have. So that has AC input, universal input range, which would be covering 110 or 220. When the equipment's not in use, the AC main would be plugged into the charger. This charger would be supplying the 48 volt battery or a 400 volt battery, depending on, if it's a hybrid system or an EV system. So once the equipment is ready for use, unplug the charger. So now the battery is supplying everything. So as you see, the high voltage battery supplies the drive inverter or any electric motors or any of the hydraulic attachments that would be on the piece of equipment. And then also through use of the BCA, the bi-directional converter as shown, 48 volt system is now running through the BCA, keeping the 12 volt battery charged and running all the control systems. Again, headlights, radio, any of the auxiliary systems. Manufacturers have been experimenting with electrification of trucks for a long time. Yard trucks or mules, which were running around in the shipping yards, if you will, were the ones that first started this. But now, it's moving on to long haul trucks. It's moving to, as I said earlier, agriculture and industrial equipment. Most of these new EV machines are electric versions of the diesel ones, so they've done the upgrades or conversions. So a lot of things like excavators, garbage trucks, front-end loaders as examples are part of this list of hydraulically powered equipment that's being driven by this. Advantage of that in running the hydraulics is these systems typically use a variable speed motor to drive hydraulic pump, and they're looking for optimum speed. When it's a diesel engine, that RPMs have to rev up to get the power needed to drive the hydraulics, whereas with the EV equipment, that power is there right now. Also, no emissions while you're idling. So a lot of requirements that are driving this is, I know Europe's ahead of us in North America, but there are requirements for vehicles not being allowed to idle anymore. So, even ambulances and emergency vehicles are looking at this requirement, because if they're on scene, there's going to be requirements that you can't leave the internal combustion engine idling. So there's going to have to be battery backup. Also, when it comes to like construction equipment that's moving in this direction, you've got noise requirements. So just, think of a diesel engine as compared to something that's battery powered. It's going to be a lot quieter, a lot less pollution. So there's a big push for this for everywhere in the world to start doing the conversion. And don't quote me on this, because I didn't write it down and I should have, but I know there is a requirement coming in Europe where I believe within the next 5 to 10 years, at least 60% of the commercial vehicles on the road are going to have to be EV type equipment. They're starting to phase out the combustion engine. So another advantage of using EV stuff would be regenerative braking. In electric and hybrid architectures, efficiency is king on this, and the more efficient the vehicle is, the more mileage you get. So one method of recovering energy is known as regenerative braking. And how that takes place is you're trying to recover some of the energy lost by using brakes. And, when brakes are applied on a vehicle, use friction to slow the vehicle, so therefore that friction generates heat. Energy is lost with heat. A couple ways the regenerative braking works is if it's a hybrid vehicle, as I covered earlier, where you have a gas engine and the battery system. On the front of the engine will be a generator. Kind of looks like an alternator if you want to picture it. It's belt driven. When the vehicle slows or coasting, or when you put on the brakes, that generator becomes a load to the engine, spins up, and is now, by the use of that load, is slowing the engine. So that energy now that's created by the generator can be fed back to the battery. When it's fed back to the battery, a bi-directional converter is required, because that energy now is coming from the brakes, and you're going to move it to charge the battery. In a full EV system, which just has an EV drive, what the designers have done is when the vehicle's coasting or applying the brakes, they've changed the poles of the engine, or the motor, if you will, to where now the drive motor becomes a generator. So as you're generating that power, it causes drag to the vehicle, slows the vehicle down. As that generator creates power, it has to be routed back to the battery. So again, the use of a bidirectional DC to DC converter can allow that. Yeah, I've covered everything there. Battery equalizers are another application that's good for bidirectional converters. In both the regenerative braking and the equalizer, it is a bidirectional topology that switches directions depending on the voltage applied. Some other applications, you'll have a BMS, and I'll cover this in a minute, a BMS system, which stands for Battery Management System, which will tell the converter to switch modes. So there's a couple different ways we've set up the platform, but to explain the battery equalizer, in some vehicle applications, they run a 24-volt system, and this is accomplished by the use of two 12-volt batteries. So if it's just 24 volts on its own, there's no need for an equalizer. But as we know from previous examples, there are 12-volt and 24-volt loads. So therefore, battery B, which would be the 12-volt loads, is also going to be discharging to also supply the 24-volt loads. So battery B, if there's no equalizer used, battery B will charge and discharge harder than if you use an equalizer. So the whole purpose of an equalizer is to equalize the charge across battery A and battery B, therefore extending the life of the battery. So when the alternator's on, as you see from the example here, current will be fed from the alternator through the bidirectional battery equalizer, and then it equalizes the charge going between battery A and B. Now when the vehicle's off, or the alternator is off, and you're just running loads off of this, 24 and 12-volt loads, the current will still run through the equalizer, so it equalizes how much current comes out of battery A and B, again extending the life of the battery. So this is a example of the bidirectional platform, but it's been altered by the use of firmware and changing some configurations so that it's now a battery equalizer. But again, it's still part of our bidirectional platform. Just another example of how the bidirectional converter can be used in the industry. So I wanted to cover some terms that I've touched on a bit in the presentation up till now. I believe I've mentioned buck mode and boost mode. So in a standard converter, which I'm showing here, which is the 1000-watt brick from Calex, it will run in the buck and boost mode. And what the buck mode is step down. So if the input voltage, is 24 volts, you've got a 12-volt out on the converter, it is in the buck mode. It is stepping down. And then if your input is lower than your output, so if you've got a 12-volt out and you've got 10 volts in, it's going to be in the boost mode stepping up. So most converters can work with boost and buck mode. They're just not bidirectional. So you'll hear the terms for boost and buck mode applied when you're looking at a converter like our brick here, which has a 4-to-1 input, which means a ratio of 4-to-1. So this has a 9 to 36 input range. That's where the 4-to-1 comes from. So this can operate in buck and boost mode, but it can't change current directions. So that's where the bidirectional converter comes in. Difference there, we go to the next screen. Difference there is it still runs in buck and boost mode, but it's really determined, the direction is determined by either the BMS, as I explained, or your voltages. So a quick overview on this is the HS battery stands for high side. So in most of the examples I've gone over, that would be 48 volts. Low side battery would be 12. So depending on, in like the hybrid application, the BMS, which is the battery monitoring system, through the use of a CAN bus, which I'll explain in a minute, will tell the converter which direction to operate in. So standard operation for a hybrid, you've got the 12-volt battery, which is the low side battery that's being charged by the gas engine, internal combustion engine, running power through the bidirectional, stepping it up in the boost mode to charge the high side battery. Anything happens where the engine's off and the system needs to reverse directions, battery monitor BMS system would acknowledge that, send the CAN message to the bidirectional. It'll change directions. Now it's in the buck mode, just like I explained earlier. However, with it being a bidirectional converter in the buck mode, current flow changes direction. So that's the basic concept behind a bidirectional DC to DC. As I explained earlier, in like the regenerative braking application or the battery equalizer, the CAN bus, it will not be controlling the direction change. It's going to be controlling the direction change. Sorry about that. The direction change will be determined by the battery voltages. So CAN bus stands for Control Area Network, and it is a system of serial communications that was developed because if you had to hook up all your ECUs in your control units, they would all have a lot of wires running around the car. So the CAN bus was developed so everything could be hooked in serial. You're cutting down on the amount of wires and you're only using a 2-wire system. And the ECUs as displayed here, you can see there's some for lights, instruments, seats, and then you've got, the digital radio, the nav system, all the way out to your engine stuff. So the central processing unit sends out signals on just a twisted wire pair, and depending on how they're coded as to, all these ECUs are on the same bus, but you're only directing communications between certain ECUs. So the CAN bus is a digital language, if you will, for allow all of the components to talk to each other, basically. Another example of that would be in a EV system, a battery management system will monitor the battery voltages, and if it needs charged, it's going to tell our BCA to run in the boost direction, charge the 48-volt battery, and also tell it to be in constant current mode because it knows it's charging a battery. Once the battery voltage tops off to the level where the BMS wants it, sends a CAN message to our converter, and it switches to constant voltage mode. So now it's just floating the charge on the battery and supplying the rest of the loads on the bus. So hopefully that's a good explanation of the CAN bus and how that works in these systems. So now I would like to cover some of the product offering we have from Calex that will play in these systems in the bidirectional. So our basic series here, this is the 3,000 watt BCA, very low profile, as you can see from the picture of the marker compared to the height of the converter. This can be mounted in a battery box. It can be mounted, in somewhere in RV storage area, anywhere that's not exposed to the environment. The BCA itself is not IP rated. It's not in a sealed enclosure. So this one was made to be, maybe if you're using it in a truck, in the cab of the truck, or in the battery well, anywhere where it's protected. But this has some of the highest efficiencies in the industry at 97%. Because of its small size, we are touting some of the highest power density in the industry. We're going to come out with 48 to 12 and 48 to 24 systems. It can be adapted to 48 to 28 if necessary. We've got disconnect switches included, so if there's any time of fault, then you don't want that fault running through the converter to the other bus, if you will. So say if there's a fault in the 12-volt bus, there's some disconnect switches so that you don't take down both the 48 and the 12. Very lightweight, only 3 pounds. And that's about it for this. This one does have the CAN communications, as I explained, so it does have constant current or constant voltage mode and can change directions with the CAN enabled feature. And then also our CAN bus also brings out diagnostics, so you can get status of what the converter is doing, and certain set points can be changed via CAN. So if it's a 48 volt in, you've got OVP, you can set that around a little bit, or over current, stuff like that. So very versatile unit. We're seeing a lot of interest in this in different applications. I've learned about some of the applications I've presented just by interacting with customers and finding out how they're using our converter. So this was the one that started it. This is the bidirectional. The next one that I'd like to show you. Same basic topology, same basic system, but these are for in harsh, ruggedized environments. So these carry a IP67 with IP6K, 9K pending. Again, these are the 12 to 48, 48 to 24. The one you see on the left is air-cooled. Now, we don't force air across it. You can run 3 1,000 watts with about 300 LFM at 85 degrees C ambient. Of course, you know, if it's dead airspace, then I think the derating curve, we're still working on some of the simulation, but it looks like the derating curve will come down to about 1.2 kilowatts, 85 degrees C, 80 degrees C with no airflow. So, you know, that one depends on your application, how much air you're going to move across it. From doing industry research and out in the market segments, it looks like the sweet spot for switching to liquid cooling seems to be around 3 kilowatts. I've looked at some of our competitors, looked at test data from engineering, and anything above 3 kilowatts, you're going to have to go to liquid cooled, or in the case of this one with 3 kilowatts, if you're in a harsh environment with no airflow, then you'd want to use the enclosure on the right, which is liquid cooled. So that one, as long as your coolant is in spec, you can handle 3 kilowatts, you know, without derating. So again, high power density, small size on these. We're less than 4.5 pounds on here, less than 2 inches tall. So we're getting a lot of interest in this from the heavy truck manufacturers that are liking our low profile and ruggedized converter. So next slide, I want to explain a little bit about what the IP rating means in case anyone's unaware of that. IP stands for ingress protection, and your numbers are different levels of protection. So like the 6 as shown in the chart we're providing, you know, against 0 ingress from dust, and then 7 is submerged. It is for 15 centimeters and between 15 centimeters and 1 meter for up to an hour, and the unit still has to work after that. Some of the ratings I've seen is 66, where that's pressurized spray, so it really depends on the application. As I said, these are going for IP67 with also IP 6K, 9K pending. So another product I'd like to show you is the battery equalizer. That came about because the BCA, we had one of the heavy truck manufacturers contact us about our bidirectionals and say, we like this, but we'd like it to be an equalizer. So we did an adaptation of that. You know, as you can see, the enclosure looks very familiar, same enclosure. Different set of firmware loaded on this to handle the equalizer duties. And, you know, some hardware has been changed out inside to handle the equalizer, but, you know, pound for pound, really it's still the bidirectional platform. Again, running disconnect switches, and we monitor low side current just to make sure everything's fine. So this is our broad market product for the 3,000 watt battery equalizer. And then coming soon, stuff that's coming out of this is not really 48 volt stuff, but we are, you know, getting ready to play in some of the EV markets. So on the left is the 3 kilowatt 400 to 12 DC to DC. You can see it's forced air cooled through the heatsink. So that's for a 400 volt battery system down to 12, you know, straight up EV systems. So far what I've seen in the market for EV systems is either 400 volts or 800 volts. 400 seems to be most of the passenger cars that are EV. 800 volts seems to be more of the commercial trucks, larger vehicles. So a spin-off of this, after this one's done, we'll be doing the 800 volt to 12. The product in the middle is our 6.6 kilowatt 400 volt onboard charger. It's got a CAN bus on it, just like the supply next to it, DC to DC, has a CAN bus. And it also has the software on board for the SAE J1772. And what that is, that's the, if you've looked at charge stations, that's the large white, I believe it's called a dongle, that's used to charge the vehicle. There is a communication protocol on most commercial chargers that if you plug in 1772, the charger has to talk to the charge station so it knows how much power to provide and what currents to provide. So most all of these new products we're coming out with for this have a CAN bus on board so that it can tie into the battery management system. And then the one on the right is we are now looking at, now that the BCA has gaining popularity and starting to get a lot of different applications out there, we've had customer feedback that, you know, the 3,000 watts really nice, but it'd really be nice if it was only 1.5 kilowatts. So starting, I believe in January, we'll kick off this project. The goal here is to take the 3,000 watt BCA and reduce it, get some cost out of it, so it'll reduce in size. reduce in power. So that'll just free up some of the designers to, if they're not needing the full 3,000 volts or 3,000 watts, I apologize, there'll be a 1.5 kilowatt available. And then stuff I didn't show here, we're also working on chargers and bi-directional DC to DCs that are 4 kilowatts that have either 4 or 800 volts on the input. And then we have 3 new chargers that'll be out following this one that'll be 7 kilowatts that have 400 volts and 800 volts. So we're lining up with the industry, doing our research, and some of these new products will be available. So I really hope this was informative for everybody. Enjoyed presenting it, and I know, as Chris said, there'll be some Q&A here, so I'll open this up to Chris for the Q&A.
All right, thank you, Michael, for a great presentation. We're now going to move on to the question and answer portion of our event. As a reminder, if you'd like to participate in our Q&A session, simply type your question into the Q&A text area on the right-hand side of the presentation window, or you can click on the Q&A icon, type your question in, and then click the Submit button. Please note that we'll try to get to as many questions as we can in the time that we have left. If we're unable to get to your individual question today, someone will get back to you after the program is over. So, Michael, it looks like we might have some questions here coming in for you, so I'm going to go ahead and start asking them of you. Our first one here, what is the maximum temperature the BCA unit will operate at while maintaining stable operation at full power?
The BCA is designed to run at 100 degrees C base plate. So not knowing all the different applications in the industry, if it's mounted to an enclosure, mounted to a bracket or framework that mounts to the rest of the frame that can pull heat out of it, that's how this is designed to run. So we're looking at the end user doing what's required to maintain the base plate at 100 degrees C. If you maintain the base plate at 100 degrees C, there is no derating. So what we've seen in the applications, and you could probably tell what it's led to, is, you know, once you move to the enclosed version where you've got liquid cooled or the fins, then obviously you've got a little bit more flexibility on temperature. But the way we specify the BCA as it sits is if you maintain the base plate at 100 degrees C, there is no thermal derating.
All right, thank you, Michael. We'll move on to another question here for you. Do you have an explosion-proof or intrinsically safe version as well?
Wow, we haven't gone down that road yet. I know with that explosion-proof, that's a certain set of connectors, or I'm probably using the wrong term there. It's escaping me right now, grommets or sealed connectors, and we haven't looked at doing that. So I'd have to, whoever's asking that, if you could reach out to me, or, you know, reach out to Calex itself, we could definitely take a look at that. But as of right now, we do not have that in our offering.
All right, thank you, Michael. We'll move on to another question here for you. Would electric forklifts be a good application?
Depends on the battery voltage. You know, I think some of the electric forklifts that I've visited are 100 volts, and we haven't really queued up anything in that 100 volt arena yet, but you know, if they're running on 48 volts, then yes, this would be a good application for forklifts. I'm really starting to explore the 100 volt niche in this arena because I know some of the forklifts, some of the electric motorcycles, some of the, I call them tier 2 or 3 utility vehicles and stuff are still using 100 volts. So really, right now I'm in the process of doing the market research to see if the 100 volt system people are receptive to that 6.6 kilowatt charger, because I've got the design team kind of geared up to, once they finish the 400 volt, if the return on investment makes sense, then we're going to roll out a 100 volt version. So I'm taking a look in that market segment, but right now DC to DC wise, we really don't have anything that supplies the 100 volt stuff.
All right, thank you, Michael. Our next question for you, do you have an either bidirectional or step-up DC to DC converter, 12 VDC to a nominal 350 VDC converter? Currently,
we don't. I know we are working on a 4 kilowatt 400 to 12, so that could be used as a unidirectional converter as a step-up. I don't have any information on that yet. Once the 3 kilowatt one that I showed here gets released to production, I know the design team is going to switch over to that 4 kilowatt. It's kind of running, I don't want to say in parallel, it's behind, but it's being worked on right now. So whoever's asking that question depends on your time horizon on your design cycle. If you reach out to us, I'm sure we could look at that because it is on our roadmap to have that converter.
All right, thank you, Michael. We'll move on to another question here for you. And just as a reminder to our audience, if you'd like to ask a question, go ahead and click on the Q&A icon, type your question in, then click the submit button. We'll get to as many as we can here in the time that we have left. If we don't get to your question today, again, someone will get back to you after the program is over. So, Michael, our next question for you, do you have a 125 VDC to 48 VDC DC to DC converter for utility applications?
Not yet, but you can bet I'm taking that down as a data point. So also depending on, the usage on that, the EAU, we do take on mods and customs depending on the industry. And what we typically do for that is if a customer comes to us and says, I need, like for example, this one, 125 to 48, then we're going to take a look and see if that would be a broad market product or if it's a niche product, which would determine whether it's a custom or a broad market product. I don't currently have it now, but that doesn't mean we wouldn't do it if we get the proper justification to do it. So again, I encourage whoever asked that question to reach out to us, calex.com, and put in that request, and we'll definitely address it.
All right, thank you, Michael. Another question here for you. Are the automotive products designed with AEC-Q components?
Yes, they are. The challenge with that right now is with these having digital control is some of the micros haven't caught up with the requirements for AEC. So we're definitely keeping an eye on that. But any of the other parts that are in the bi-directional or the equalizer or the charger or that 3 kilowatt DC to DC are AEC-Q 200 parts.
All right, thank you, sir. Another question has come in that asks, do you have an EV communication controller that is ISO 15118 compatible with EVSE chargers 15118 compatible?
We do not, and we haven't explored that market. We don't do any of the battery management systems or the communication modules like that. No, so the answer is no, and I really haven't even started to look at that market segment. So.
All right, Michael, we have time for just one more question for you here. Our last question, doesn't OSHA define HV at over 50 volts?
I don't know. I'd have to look at that. I'm going to write that down and look into that because I put the SELV requirement out of UL, Underwriters Laboratory, the 60950 that applies to telecom, and that SELV limit has moved over into some of the automotive stuff, but I have to look at that. That's a good question for me to research. As my knowledge right now, I can't answer that. I don't know if that's how OSHA defines that or not.
All right, well, thank you, Michael. That does look like all the time that we have for questions for today. I'd like to thank Michael McNally, the Battery Show and Electric and Hybrid. Appreciate your time and your expertise on today's topic. Also like to thank our sponsor, which was Calex Manufacturing, as well as everyone else in the audience. We appreciate your time and attention and participation in today's event. Within the next 24 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. And please feel free to invite your colleagues and peers who may not have been available to listen to today's event. And once again, if we did not get to your question, again, someone will get back to you after the program is over. This webinar is copyright 2020 by Informa. The presentation materials are owned by or copyright by the Battery Show and Electric and Hybrid and Calex Manufacturing. And the individual speaker is solely responsible for his content and opinions. On behalf of our guest, Michael McNally, I'm Chris Keach. Once again, we'd like to thank you for joining us, and we hope you have a great day.